As the world's leading producer of oil and natural gas, the United States relies on its vast rail system to safely, efficiently, and cost-effectively move crude oil. 99.997% delivered without incident. However, communities should always be prepared if an incident were to occur. This information is meant to supplement, not replace or contradict first responder training. This video is one of several educational options for those first responders and emergency management personnel who are interested in learning more about preparing for and responding to flammable liquids fires. Other courses include the TransCare Crude by Rail Safety Course, Cert-C computer-based 4-hour course, PHMSA Tripper Program, TEACS 3-day hands-on training, Cert-C 3-day hands-on training. Most importantly, throughout the response to an incident, first responders should follow their incident command protocols. They should also be prepared to integrate railroad personnel upon their arrival in order to have a smooth transition to a unified command. While some amount of hazard assessment and initial response may take place, it's critical that responders communicate from the beginning with the railroad and recognize their processes, resources, and capabilities. This program is designed to provide general guidance on the following topics: why we move crude by rail, recognizing the hazards, rail cars that carry crude oil, fire response, spill response, and incident command. The U.S. has seen dramatic growth in the production of crude oil domestically over the past few years, changing the way crude oil is moved throughout the country and how much travels by rail. While movements of crude oil by rail have significantly increased over the past 6 years, the percentage of crude oil and petroleum products moving by rail is still relatively low as a percentage of all freight rail cargo. Railroads have a strong record for safely moving hazardous materials. Since 1980, train accidents with a HAZMAT release have declined 84%, while HAZMAT carloads have tripled. All of this movement is highly regulated, involves specialized employee and local first responder training, and is done with the utmost care to reduce risks. If an incident occurs, identifying hazards should be one of the first steps upon arrival. If HAZMAT is present, recognizing the placard is a quick way to determine the primary hazard. Placard identification is a valuable way to identify the contents of tank cars. This information should also be compared to the railroad shipping papers. Responders should use readily available references to analyze the incident. The Emergency Response Guidebook, otherwise known as ERG, provides general guidance for the initial phase of an incident. Contacting the shipper for product-specific information is also recommended. The ERG is also available in an application for tablets and smartphones, making it very handy to reference on-site. The AskRail app is a safety tool that provides first responders immediate access to accurate, timely data about what type of hazardous materials a rail car is carrying, so they can make an informed decision about how to respond to a rail emergency. AskRail is a backup resource if information from the train conductor or train consist is not available. Railroad shipping papers are a list of all of the cars in the order they are on the train and can be found with the conductor in the lead locomotive. The railroad shipping papers may also provide response guidance for all of the hazardous materials on the train. This information is found after the ordered list of all cars. It is also important to verify the information on the shipping papers by comparing the railroad shipping papers to the cars in the train. The identification number, proper shipping name, and hazard class should match the placard found in various locations. Many of the characteristics of crude oil should be taken into account during a response. So should the characteristics of the tank cars. There are key features which help prevent a release when a rail car is damaged. Contact your railroad personnel for detailed information about a tank car. The primary hazard of crude oil is its flammability, so we need to understand what is required if there is a release and the oil ignites. However, to promote the most conservative response posture from a safety perspective, firefighters should treat crude oil as you would a flammable liquid such as gasoline. It is unlikely that an incident like this will happen in your community, but that doesn't eliminate the need for planning and training. Injuries and illnesses from hazmat exposures at derailments are very rare. We use our knowledge, training, and personal protective equipment to protect us from hazardous material exposures. Responders should prepare for spilled products when responding to a flammable liquids train derailment. Recent train derailments have revealed a typical timeline of events that first responders need to take into consideration when responding to these emergencies in their community. During the initial size-up, there could be opportunity in the first 15 to 30 minutes of a derailment to act offensively and extinguish fires if the responders can access the area and have appropriate equipment and resources to control the fire. Any action at this point should be directed by the authority having jurisdiction. However, no such action should be taken if responders don't feel comfortable with size-up information. If pressure relief valves, or PRVs, are actuating, or significant pool fires are present, responders need to be aware that heat-induced tears or intense heat exposures are potential threats. Typically, within 6 to 8 hours, the emergency starts to reach equilibrium. Tank cars that are going to fail will likely have already failed and may be in a free burning state. When this equilibrium has been achieved, the responders can then evaluate their tactical options. During a derailment that involves a potential release of hazardous materials, the railroads and their contractors will conduct air monitoring to quantify the exposures to the workers and the community. This data may be used to decide what protective actions are needed. Before choosing the proper personal protective equipment, we need to consider the exposure. As a first responder, the primary concern is protection from fire. Structural firefighters' clothing will provide protection from fire exposure, and a self-contained breathing apparatus provides protection from inhalation exposures. Railroad crews and cleanup contractors will be called on to clean up the environment and may need to consider level C protection if skin exposure to crude oil is likely and flammable atmospheres are not likely. If cars are involved with intense pool fires or torch fires, they are subject to near-term failure. These failures have been known to occur in 20 minutes or less. This is a highly variable, unpredictable phenomenon. Where flame impingement has occurred, consult the ERG for protective actions. It is extremely important that you are aware of this phenomenon. Avoid rushing in, and always think safety. Now that you have the public protected, you need to decide the next step. Should you conduct defensive operations, offensive operations, or non-intervention? Defensive actions are conducted to ensure the incident does not spread, causing additional property damage or threat to the public. Offensive actions are conducted in an attempt to control and extinguish fires. Non-intervention is to allow the crude oil to burn until the bulk of the crude has been consumed. Unified command will make the decision to extinguish the remaining fires. After the size-up, you need to consider the properties of crude oil when determining what actions, if any, you should take. Remember that you should use the same RECIO strategy as any other fire, but also make sure to understand the properties of crude oil will dictate your response, and that only suitable extinguishing agents should be used to attempt to extinguish crude oil pool fires. One of the defensive actions at your disposal is to cool tank cars that are being exposed to fire. Before you decide to attempt to cool tank cars, you need to ask several important questions. Is there a benefit to cooling cars from a distance? Meaning, can you deliver water to the target, and is there risk to your personnel? Are there other exposures that you need to protect, such as structures, grass, and trees, that could cause the fire to spread? Do you have an adequate water supply, and can it be maintained? Can the runoff be contained? One of the first objectives would be to cool cars, minimizing the potential of a heat-induced tear. You may not need to cool tank cars that have holes in them or are jacketed. For intact cars, the cooling water should be directed toward the vapor space, which is the top of the car and at the point of the flame impingement. Avoid water or foam getting inside a breached tank unless it is part of your tactical response. Water in breached tank cars can lead to dangerous conditions. You will know if a cooling tank is effective when the water spray is not evaporating on contact with the tank. Cooling may not be effective when you hear a loud, shrill noise, much like air escaping from a gas station hose, which would be from the tank's pressure relief device, or if you see blisters forming in the steel on the top of the tank car. These are clear indications you should consider pulling back. Foam applications during a derailment will be extremely challenging due to the track structure's design. Cars frequently end up very tight in a side-by-side configuration, making it difficult to get an effective blanket of foam. Before you attempt offensive actions, you must make sure you have enough properly trained responders in order to have a safe operation. Prior to conducting offensive actions, you need to determine whether you have enough foam or dry chemical, can apply it in the correct application rate using the right methods. Also, foam needs to be reapplied to maintain the blanket. Clearly, you must have a large enough water supply to sustain operations and prevent reignition. Responders should be aware that tactics should consider the impact cooling water may have on the integrity of a foam blanket. Typically, crude oil will float and burn on water. It is imperative that you understand specifically where the crude is flowing. Crude oil getting into storm sewers may cause the buildup of flammable vapors or cause significant damage to surrounding environments. It is very important to keep any crude oil and runoff safely contained at the source or diverted away from exposures and sensitive environmental areas. Remember, reignition is a dangerous possibility. Continuous air monitoring should be conducted to determine LEL and H2S levels. It's not recommended that you allow responders to enter a foam blanketed area because it could cause the escape of flammable vapors, which increase the probability of reignition. However, if it is imperative that responders enter a foam blanketed area, foam lines should be continuously used to maintain a robust foam blanket. As with any immediate rescue actions, a risk-benefit analysis along with capability needs to be quickly and judiciously evaluated. Our first responsibility is always to protect the public. For crude oil, the ERG has general guidelines for isolation and evacuation. Every incident is unique, and the situation and location will dictate the isolation and evacuation distances. If you are unsure whether the evacuation and isolation distances are prudent, consult available resources, including the railroad or the shipper. Saving lives is the most critical element of a response and must be executed with an understanding of potential hazards at the direction of a qualified incident commander. The railroads will take the lead for remediation, maintenance of tracks, and rail cars. Remember, there is no substitute for using safe response practices. Knowing risks, knowing the rules, and working safely is up to you.